Now let's talk about expanding. So reminder, these are the three properties of logarithms that we're using. If you add two logarithms together that have the same base, you can rewrite them as a single logarithm. You would multiply what's in their parentheses. If you subtract two logarithms, when you rewrite it as a single logarithm, you divide. The piece that had the negative in front of it goes in the denominator. And then if you have a coefficient in front of your logarithm, you can bring it inside as an exponent. If you start with multiple logarithms and write them as a single logarithm, it's called condensing. We are going to go in the opposite direction and expand. So we're going to start with a single logarithm and break it apart, pull all of the exponents out, break it apart into multiple logarithms. So here are I think I have 6 examples. Expand, or rewrite in terms of sums and differences of logarithms. When we expand, first break apart into multiple logarithms. Then deal with exponents. So this is the opposite order of what we did when condensing. All right, so first let's break it apart. Everything we see that is multiplied or divided is going to break into separate logarithms. So this is x times y squared, which means that we can break it up into two logarithms, an x1 and a y squared one. Because they're multiplied, we would add our logs. So x times y squared means we have an x log and a y squared log. Now deal with your exponents, so bring your exponent out front. Only the y is squared, so the squared, the 2, becomes a coefficient only on the y logarithm. And now we're done. Second example, it doesn't look like we need to expand any because a lot of times people think if you see 8x, it all is just one thing. But technically this is natural log of 8 times x, which means that we can break it apart into an 8 natural log and an x natural log because it's 8 times x. So I'll have my 8, I'll have my x, and because this is 8 times, I need a plus sign in between. There aren't any exponents for me to pull out front, so this is all I have. All right, third example. I need to remind you of this property of exponents that we talked about a long time ago. If you take the 8th root of x to the b power, you can rewrite this as x to the b over a power. So what we're going to have to do in these next few examples, I'm giving you radicals. You're going to have to rewrite them in exponent format. And now once they're in exponent format, we can use this property or break it apart first and then use this third property. We don't have any properties that tell us how to deal with radicals or square roots or cubed roots, but we can rewrite this root as an exponent, and we do have properties that tell us how to deal with exponents. Let's rewrite this. There is an implied 2 here and 1 there. I would rewrite this as log of x y to the 5th power all to the 1/2 power. Then remember properties of exponents, because this is x times y to the 5th. I can distribute my 1/2, and I'll have log of x to the 1/2 power and y to the 5/2 power. 5 times 1/2 is 5/2. Now let's split apart into multiple logarithms and deal with our exponents. First split, then deal with your exponents. Okay, this is x to the 1/2 power times y to the 5/2 power. So I can rewrite this as log of x to the 1/2 power plus log of y to the 5/2 power. Now that it's broken into multiple logarithms, bring your exponent out front. And so my final answer is 1/2 log of x plus 5/2 log of y. There you go. All right, let's look at one that's a little more complicated, but it still has to do with a root. So first we need to rewrite our root here. If you don't see an exponent, it's implied to be a 1, and I have a cubed root here already. So I can rewrite this as log of y to the 4th is on top, but in the bottom I have x z squared to the 1/3 power. Distribute your 1/3 to both of these exponents. So x to the 1/3 power and z, 2 times 1/3 is 2/3. Now I can split it apart into multiple logarithms. I'm going to have 3 pieces here. I have a y piece, an x piece, and a z piece. Anything in the denominator needs a minus sign. In front of it. So when I break this apart, I will have log of y to the 4th minus log of x to the 1/3 minus log of z to the 2/3. I can bring my exponents out front, so the 4 comes in front of the y log, the 1/3 comes in front of the x log, and the 2/3 comes in front of the z log. So my final answer is 4 log of y minus 1/3 log of x minus 2/3 log of z. All right, 2 more examples. You may want to try and pause the video maybe as I go through each one of these examples to try them yourself. I should have said that from the beginning, but it's not too late to try these 2. Let's rewrite our radical as an exponent. That means on top, cubed root of x to the 4th is x to the 4/3 power. In the bottom, I'm going to leave it as x plus 7 to the 5th power. Do not distribute your 5 inside there because there's a plus sign. We distributed when these were multiplied together, there wasn't a plus or minus, and we distributed again when they're multiplied, there's not a plus or minus. Do not distribute if you see a plus sign. That means when I break it apart, I have an x piece and I have this entire piece stays together because the plus sign, or if that had been a minus sign, plus or minus holds it all together. That means that this would be log of x to the 4/3 power minus, because it's in the denominator, log of x plus 7 to the 5th power. So we cannot break apart the x plus 7. But I can still bring my exponents out, and because this 5th power is to both the x and the plus 7, I can bring it out front. Final answer is 4/3 log of x minus 5 log of x plus 7. Final example, this one I have changed just a little bit from what was in your notes. I made this a squared here because I want you to see it's not going to be any different from this example here. First, we need to get rid of our square root. Remember, square root implies that there's a 2 here. So I can rewrite this as log of 4 times x squared over x squared plus 7 to the 5th power, all to the 1/2 power, where the denominator is all to the 1/2 power. I don't like having weird double exponents like that, so we can rewrite that as just x squared plus 7 to the 5/2 power. All right, let's split it apart. On top, we have 4 times x to the 5th. Don't forget, you can break these two apart. It is 4 times x to the 5th. And on bottom, we have this entire thing has to stay together because there's a plus sign with that x squared and 7. Anything in the denominator is a minus. That means we have log of 4 plus log of x to the 5th minus log of x squared plus 7 to the 5/2 power. Bring your exponents out front. Notice I'm not bringing the squared out front, just the 5/2. And that's because only the x is squared, the 7 is not also squared. If you want to bring an exponent to the front, the entire thing has to be to that exponent. And I can't break my x squared and 7 apart because of this plus sign. If I could, then I'd bring the squared out. But there's a plus there, so these two don't break apart, they stay together. And since only the x is being squared and not the whole x plus 7, we leave that squared inside. That means my final answer is log of 4 plus 5 log of x minus 5/2 log of x squared plus 7. If you plan to take calculus, you are going to use these properties here to do logarithmic differentiation, which just means you're going to have to break your logs apart before you take the derivative. And you will be breaking apart things like this example F that we just did. Sorry, that's the exact same thing. And this example E.